Today we're going to begin section 5.5, Pythagorean Theorem. Now, we've talked a little bit about the Pythagorean Theorem in the past, and you've probably seen it a little bit when we worked on some testing questions, but we're going to go through it and then its uses in the next few days. Central question today is, what is the relationship among the legs and the hypotenuse of a right triangle? First of all, we need to know that a right triangle is a triangle with one right angle. Now remember that means that it has an angle of 90 degrees. The legs are the sides that form the right angle, and the hypotenuse is the side opposite the right angle. It's also the longest side of the triangle. So some things that we need to know. And let's just take a look at a little picture. Let's draw a picture over here on the side of our notes. Remember that we show a right angle by putting a box in that angle. So we know that this is the right angle, making this a right triangle. That means that these two sides, the two sides that form the right angle, are the legs. And this side, the one directly across from the right angle, is the hypotenuse. So you can go ahead and write that just to remind yourself. Okay, so let's take a look then at the Pythagorean theorem. We're going to write it in words, and then we'll write a formula and a picture to kind of help us with it. The Pythagorean theorem says that in a right triangle, so it only works for right triangles. Anytime you see a right triangle, you should at least think of the Pythagorean theorem. In a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Now that sounds a lot worse than it actually is. If we actually draw it out, and you've probably seen it before in a formula, it's a squared plus b squared, so there's the sum, meaning add, of the length of the legs squared, a squared plus b squared, equals the square of the hypotenuse, which is c. Just draw us a little picture again. This one may be a little less detailed than we did before. We've got a, b, and c. Now notice that on the first picture I put a down here and b here, and on this one I put a here and b here. It doesn't matter with the legs. The only one that actually matters is the hypotenuse. The one directly across from the right angle must be c. Okay, so the Pythagorean theorem describes the relationship between the lengths of the legs and the hypotenuse for a right triangle. Remember, it only works for a right triangle. You can use the Pythagorean theorem to find the length of a side of a right triangle when you know the other two sides. So let's take a look at some examples. All right, in our first example, it says write an equation you could use to find the length of the missing side of each right triangle. Then find the missing length. Round to the nearest tenth if necessary. Notice that we have the length of the legs, but we do not have the length of the hypotenuse. The first thing I want you to do each time is write the formula. It's something you need to memorize, and plus it'll be easier for you to substitute in correctly if you write it each time. So let's just call this A and this B. Again, remember that I said you could have called this one A or this one B. I just chose this one is A and this one is B. So we'll substitute in. A is 9, B is 12, and we don't know C. Now, if you need to use a calculator to figure out 9 squared and 12 squared, you can do that, but I think we should know that 9 squared, 9 times 9 is 81, and 12 squared, 12 times 12 is 144. Remember, we worked on squares and square roots earlier in the year. So now we have that 81 plus 144 equals c squared. 81 plus 144 is 225 equals c squared. You should remember from previous lessons how we solved something when we had c squared but we needed to find c. Remember that we took the square root of both sides. And also remember that when you take the square root, you actually have two answers. You have a positive and a negative answer. If you need to use your calculator, find the square root of 225, that's fine. Remember on our calculators, the ones that we have at school, and hopefully you have one similar to it at home, you take the second x squared button and then type in 225 equals, and you should get plus or minus then 15 equals c. So the equation has two solutions, 15 or negative 15. But let's use our common sense because the length of a side must be positive, right? You can't have that negative length. So the length of a side must be positive. So the hypotenuse is going to be 15 inches long. Let's take a look at the next example. Now in the next example, we are given one side and the hypotenuse, and we're asked to find the other side. This one takes a little bit more work, but it's not that difficult if you follow my instructions and you write out your formula first. So we have a squared plus b squared equals c squared. We don't know a, so we'll leave a squared here. B squared, remember this is b because this side, the one opposite the right angle, always has to be c. So we know this one is b, so 17 squared equals 20 squared. If you need to use your calculator to figure these out, 17 times 17 is 289, and 20 times 20 is 400. Now we're going to go way back to earlier in the year when we first solved equations and remind ourselves how we get this by itself. Remember, if we're adding 289, we have to subtract 289 from both sides. So I do want you to show that. And that's going to leave me with a squared on this side and 111 on this side. Again, once we get to this point, we still need to find a, so we're going to take the square root of both sides, and we know that that's going to be a plus or a minus here. We've talked about that before. Square root of a squared is a, and we're going to get plus or minus when you working on your calculator, you're going to get 10.53565375, but we're going to round to the nearest tenth, so we're going to get about 10.5. So we're going to check for reasonableness. First of all, we know that the hypotenuse is always the longest side in a right triangle. If you don't know that, you definitely need to highlight it. That's going to be important. Hypotenuse is always the longest side in a right triangle. And since 10.5 is less than 20 centimeters, the answer is going to be reasonable. So our answer is going to be approximately 10.5 centimeters. Now remember that we have the little squiggly equal sign to show approximately because we had to round it. We're not giving an exact answer. All right, take a look at the next page. There are two problems for you to work. Notice that in the first problem, you're going to be finding the missing hypotenuse. So let's just go ahead and name this is A and this is B so that you everybody will be consistent. And remember also that you are going to write your formula first. Notice that it says round to the nearest tenth if necessary. Use the notes that we just took to work your problem. In the next practice problem, notice that we have C because it is the side opposite the right angle. And let's just say that we have A because this one says B. So you'll write first and then substitute in what you know and solve it. Once you have those finished, Bring those to class tomorrow and we'll go through them together and make sure that you understood how to do them. So pause the video for just a minute and work those problems and then come back to finish. Okay, now that you have finished those problems, let's take a look at the next concept. The next concept is the converse of the Pythagorean theorem. The converse of the Pythagorean theorem just states that if the sides of a triangle have lengths A, B, and C units, such that a squared plus b squared equals c squared, then the triangle is a right triangle. Again, this sounds a lot harder than what it actually is. So basically it says that if you reverse the parts of the Pythagorean theorem, you have formed its converse. So the statement is, if a triangle is a right triangle, then a squared plus b squared equals c squared. Its converse is that if a squared plus b squared equals c squared, then it's a right triangle. So basically just saying the opposites. Let's take a look at the example. It says the measures of three sides of a triangle are 5 inches, 12 inches, and 13 inches. Determine whether the triangle is a right triangle. Well, the first thing that we need to remember is that the hypotenuse is always the longest side. So here we have 5, 12, and 13. So we'll go ahead and put 13 in for the hypotenuse. And then we'll put 5 squared plus 12 squared here. 5 squared is 25. 12 squared is 144, and 13 squared is 169. If you don't know that, use your calculator to figure it out, but those are good numbers to know the squares of. 25 plus 144 is 169. So what it's saying is that a squared plus b squared does equal c squared. Both sides are the same, so yes, this is a right triangle. Take just a minute and work the two problems at the bottom, pause the video, and then bring these problems with you to class tomorrow. All you have to do is work them like we did the example above and say yes or no, it is a right triangle. If they're equal, then it is. If they're not equal, then it's not. Bring those to class tomorrow and we'll go through them together.